Good day to fellow panelists that will be watching this video. I am Ijui and I will be presenting my FYP on Mobile Warehouse Management System. This project is initiated by Hotai Electronics to replace the traditional system that uses computers and handheld scanner. And this leads to our first problem statement, which is the mobility issue, because the current system is installed on computers with connected scanners, which is stationary. Although there is wireless scanner, but it is limited to memory and it still needs to go back to the computers to control and confirm the operations. When the mobility issue has been solved, then it leads to the second problem statement, which is the confusing warehouse interior, as now employees are free to move around in the warehouse and the risks are look alike when they are stored inside racks. An employee will take more time and more effort to find the racks that contain the required material. Hence, this project is developed with a few objectives. The first objective is to develop a mobile warehouse management system on Android scanner, and this is to increase mobility. The second objective is to visualize the warehouse map to save time. And the third objective is to develop path routing optimization to increase effectiveness of the warehouse operations. For this project, I have proposed a solution of mobile warehouse management system with two subsystems, inventory management and warehouse mapping. Under inventory management subsystem, there are two functions which are barcode scanning and generate reports. On the other hand, warehouse mapping has three functions which are visualize warehouse map, optimize the rack space utilization, and calculate the shortest path to the target rack. The technology deployed in this system is, in terms of software, is Microsoft Visual Studio 2019, Microsoft Azure SQL Server for database, Azure Ad Service for backend service, and in terms of hardware, the system will be installed on MC3300S mobile computer, which is an Android scanner. This is the architectural diagram of the system. Employee will use the Android scanner or the device to do all the warehouse operations, and the data of the operations will pass to the web service via internet, and the web service will process the data and perform SQL query on the database. After that, the database will return the message to the device via web service, and the device will display the message on screen to enrich the employee. For the path routing that is implemented in this system, I use the algorithm breadth-first search to calculate and find the shortest path. As you can see, the left side of the string shows parts of the code that I write using breadth-first search. Next, the condition for rack space utilization, I optimize it by showing the available space of each rack in a glance when the user opens the map. For your information, the maximum rack space is 1000. Hence, when a rack has a rack size of available rack size of more than 500, which is a half, will be shown in green color. When the rack is have less than half of the space available, then it will show in yellow. If the rack is fully occupied, then it will show in red. This is a module diagram of the system. There are four main modules: login module, database module, inventory management module, warehouse mapping module. In my proposed solution, inventory management module has two main functions, which is barcode scanning and generate reports. As you can see, the first three use cases will be under the barcode scanning, and the wheel report will be under the generate report. Warehouse mapping module will have in my proposed solution has three main functions, which are visualize warehouse map, which is indicated by view warehouse map, and the second is the optimize rack space utilization, which is indicated by show racks with size, and the third function is calculate the shortest path to the target rack, which is indicated by show path to racks and make requests. Make request is additional functions for user to make requests to find the racks that contain the required materials. To the system demo, first we will look into the login and home screen. For the login screen, it will prompt for login ID and password. When the user keys the login ID and password and press at login, this login ID and password will pass into the database to find matching. If there is no matching, it means that the user is not authorized, or login ID or password is invalid. And in this case, this is an invalid login ID and invalid password, indicating this user is not an authorized user for this system. When the user enters the right login ID and right password, then the database and press login, then the login ID and the password will pass into the database, and the database will find the matching and return an employee and will return the name of the login ID. In this case, 1002 is actual Debbie, and the name will show on the home screen. And this is the home screen of the system. And that's it for the login and home screen. And moving towards the scan receive. For the scan receive, it will prompt for part number and quantity. For these two inputs, barcode scanning can be used to input. And here is the demonstration of the barcode scanning. And after scanning and the data has been inserted into the right input area and press enter, a pass message is popped up, indicating the data has been inserted into the database. Now is a demonstration of a validation. As you know, the maximum size of this system is 1000. Hence, any material that is exceeded quantity of 1000 cannot be accepted. Hence, a field message will pop out indicating this is rejected. Moving to the scan store item. For the scan store item, it will prompt for serial number and red ID. And for your information, serial number is the combination of part number, quantity, and a random number. And most importantly, serial number is not a part number. In this demonstration, it will post out a field message because the serial number is not a valid serial number. It is a part number, but not a serial number. So a valid serial number should be entered in this context to successfully inserted into the database. In this case, this is a valid serial number, and a pass message is popped up indicating the data has been inserted into the database. And that's it for the scan store item. For the scan issue item, it is similar to store item. It prompts for a serial number and production line number. And it's similar to the receive and store item. Barcode scanning is enabled. And as you know, part number is not a serial number. Hence, the demonstration now will post out a field message because the serial number is not a valid serial number. Hence, a valid serial number is entered. Then it pop out a pass message indicating the data has been inserted into the database. And for the wheel report on material, it will prompt for part number. And it also enables barcode scanning. And the scan result will appear in the input area. And when the user press on the search icon, then all the materials with the same part number will appear on the screen. And information like grade, line, or quantity and location will be shown. And now for the validation, If a invalid part number is entered, the system will try and find the matching part number. If there is no matching part number in the database, it means that this part number is not exist in the database. It means that this part number is not a valid part number, and hence it will pop out an error message. And that's it for the view report. And for the view warehouse map, it will the warehouse map is generated by the system as shown as on the video display. As you can see, the racks are displayed in colors, and there are 3 colors, which is green, yellow, and red. And the rack can be pressed and to check out the exact rack size, and there is a navigate button on it. And when the user press on the navigate button, then a shortest path will be shown on the screen, as shown on the video display. And moving towards the make request. For the make request, it enables users to enter part number and quantity to make requests, and the system will analyze on this part number and quantity and choose the suitable racks, and then it will show the shortest path to the chosen racks. In this case, the prompt part number can be inserted using scan, but the quantity can only enter using manually. And another thing is the validation. If the requested quantity is more than the total quantity in the database, then it will pops out an error saying the quantity part number or quantity is invalid, and in this case is the quantity is invalid. Now I will be showing a valid request, a successful request. When press enter, it will show on the screen as a list on the screen, and this represents the request has been saved in the system. Now I will be putting in some dummy data. For now I will be testing on the non-exist part number. If a non-exist part number is requested, the system also will identify it and pops out an error message indicate the request is rejected. Here is the dummy. Here's are the dummy data to test out how the system analyze and choose the destination racks. And when the user press on the arrow button on the bottom, then it will go back to the warehouse map and it will display the shortest path. In this case, rack 1 and rack 10 contains all the materials that is requested just now in this scenario. And that's it. In conclusion, the proposed system is developed specifically for Android scanner, which is MC3300S mobile computer. The application is programmed in C# with the platform of Xamarin Android. There are 2 main modules in this system, which are inventory management and warehouse mapping. Inventory management involves barcode scanning and will report on score and issue risk. And warehouse mapping contains the visualization of warehouse as a map as well as path routing to the racks. And that's all from me. Thank you.